We are discussing about GATE 2007 ECE paper, and this question is related to electronics. A P plus N junction has a built-in potential of 0.8 volts. The depletion layer width at a reverse bias of 1.2 volts is 2 micrometers. For a reverse bias of 7.2 volts, the depletion layer width will be. What will be the depletion layer width if the reverse bias voltage changes from 1.2 volts to 7.2 volts? And we know the equation for the depletion region. Depletion region is going to be, width of depletion region is indicated as W with 2 epsilon V by Q into ND to the power of N. This is the equation for the width of depletion region of a P plus N junction. P plus N junction is nothing but width of depletion region more penetrates into lightly doped side than heavily doped side. Here it is, N side is lightly doped, N side is made up of donor concentration, so that you will get ND in the equation. If it is PN plus junction, at that time you will get Na. Otherwise you will get 1 by Na plus 1 by Nd in this equation. 2 epsilon V by Q into 1 by Na plus 1 by Nd, that is for the general PN junction. And this equation is related to the width of depletion region under P plus N junction, and N specifies where N is equal to, where N is equal to 1 by 2 for step graded, or it is also called as abrupt PN junction, abrupt PN junction. And when is equal to 1 by 3 for linear graded PN junction, linear graded PN junction. So whenever it is not specified whether it is going to be linear graded or whether it is going to be step graded, always the assumption is nothing but this is by default. Okay, so this we can say it as default case. So N is equal to 1 by 2. From this one we can say that one W is proportional to V to the power of N, that is junction voltage under reverse bias, where Vj is equal to, okay, so here it is, N is equal to 1 by 2 and this is Vj where Vj is equal to junction voltage, reverse voltage plus built-in voltage. So from this one we can say that one W is proportional to square root of Vr plus Vbi. This is what the equation for W. So we will consider Vr1 as 1.2 volts. Whenever Vr1 is at 1.2 volts, at that time the 2 micrometers will be treated as W1 and this will be treated as Vr2, reverse bias voltage, and depletion layer width will be treated as W2. By that time we can write W2 by W1 is equal to, okay, if you remove the proportionality constant you can write something as K, that K get cancels, so you can directly write it as Vr2 plus Vbi. This is Vr2 divided by Vbi, square root of Vr1 plus Vbi. So W2 divided by W1 is nothing but 2 micrometers into Vr2 is 7.2 plus 0.8, that is nothing but 8, divided by 1.2, Vr1 is 1.2 and Vbi is 0.8, so that is 2. So what you will get is nothing but 2. So W2 is equal to 2 into 2 is nothing but 4 micrometers. So the width of depletion region is going to be increases by 2 times. So the right option for this question is A. Thank you.